And now we're on part 3 of 4. So we're almost done here with land and resource use. Unit 5, man, it's a big one. But we're going to look at overfishing. One of the best examples is this cod because it's been studied a lot and it's delicious. But so the amount of cod that has been caught, you can see in the 1970s, it really peaked, but then it crashed. So when you overfish, stocks go down and you have this much smaller population. And so even though you have the same technologies, you're catching less. And if you can look in this, if you look in this graph on the left there, you can see just that happening. Now on the right there, you can also see that as I'm increasing my catch, the number of species that I'm actually catching goes down, which shows us that my species density, or like the number of species or species richness, is actually going down. And so the more you overfish, the more depleted your stock gets of some species. And as those species get depleted, right, there's less and less of them to actually catch. And this can be super detrimental to people who depend on this for a living, on these small scale fishermen or fisher people. Another major thing that impacts our earth, right, is mining. And we need material, right? And so mining is one way to get it. And so what we're mining for is actually minerals, and we get that from ore. So ore is actually the rock that contains the material, or economically valuable material. So lots of metals, sand, salt we also mine for. But once we actually get that ore, we actually need to refine it. And so we get the excess or the tailings off of our ore, and then we refine it. So we heat it and separate it out from its impurities through heat, pressure, and chemicals. And so here is a nice little picture about kind of how, a little vocab list as to what we're looking at. So, right, we're looking at the ore, and we want to separate out the ore from this excess rock that it's in. And then from that, we get our tailings, like more excess stuff, more excess waste, and we get a concentrated ore of very high mineral content. We refine it, and you end up with slag, which is all that impurity and waste product, and then the pure metal. And so our ore is, finite as well. Seems like a lot, but on the human scale, that's a lot, right? We have to think about the earth, and are there going to be humans in another 40 years or 120 years? Well, maybe there might not be any iron left, and then what would he do? But as we mine for these minerals, we're going to have to get less pure ore, or really, really low grade ore, more often, because we've already mined out the high quality ore. And so what does that really mean, right? These high grade ores have very high mineral content with very few impurities, so we don't have as much waste. Whereas in low grade ores, you have a very low mineral content, more impurities, a lot more energy needed to actually mine and refine this, more waste product, like I said, and because of that, obviously more pollution. And so if you look at the graph up there, you have the amount of high grade copper that that we have mined, in the past, and it's decreasing because we have to go with lower and lower grade ore because we've already mined the good stuff. And so here's another infographic on how we can mine ore. So there's surface mining and subsurface mining. And so surface mining includes strip mining, open pit mining and mountaintop removal. They're basically what they sound like, and you can see really the pictures do a better job than I would explaining what they are. And subsurface, right there, you're actually going underground, and this is pretty dangerous for people, very expensive, because not only are you starting to like drill down into the earth and make things stable, you're also paying for like externalities like health of your workers and insurance and stuff like that. I mean, of course you are worried about that with other things, but because the subsurface is so much more dangerous, those are obviously more expensive. And so when you hear about coal miners trapped in the mine, this is it, right, in the subsurface mine. So what are the effects of mining? Well, there's obviously habitat destruction. I mean, you're literally taking away the land and moving it. There's carbon emissions from the actual machine combustion of fossil fuels as you're doing it. So the machines you're using are combusting fossil fuels to mine. There's tailings and slag, which are waste products that have stuff in them that react with water and air to produce other stuff, which we'll talk about. There are particulates in both mining and refining. So when we talk in the future about air pollution, particulate matter is one of the criteria air pollutants. The smaller the particulates, the more harmful it is. I'm sure everyone has heard of black lung. And so right here's a beautiful picture of a coal miner's lung. And then methane is also released because, especially in coal, you have methane present in the coal seams that you're mining for, and that gets released. And so that's actually super dangerous in subsurface mining for people because it's explosive, and people can, you also need oxygen. And so if it's full of methane, that can be really toxic for you. But not to mention, methane is also a major greenhouse gas. So of course mining has an effect on water and groundwater. Anything that happens in the water really will percolate down into the groundwaters or infiltrate down into the groundwater. So, keep that in mind. Right, there's sedimentation. If I'm breaking apart the earth with surface runoff, you're going to end up with sediment in nearby water bodies. Acid mine drainage also happens where the water infiltrates down into the mine and actually reacts with some sort of sulfur containing material, which is a lot of stuff, depending on what you're mining for. In the picture here, it's pyrite, or if your coal has a lot of sulfur in it, depending on the type of coal. But nonetheless, you end up with sulfuric acid, and that acids will dissolve metals into the water, and then the water drains out of the mine, and you end up with acidic, metallic, right, or metal contaminated water. And that's no good for aquatic life or really any life. And so just in leading into that, or leading from that, right, is metal contamination. So I'm mining for metals, there's going to be metals exposed. And finally, we're at impacts of urbanization. Actually, it's not finally. There's a little bit more, but almost done with part 3. But yeah, urbanization. So I always like to bring up this IPAT, right? Because the impact that people have on the environment, it has to do with the population, affluence, and technology. And so depending on what's happening with each of these things will impact differently. So if your population is big, it's going to have a larger impact. If your affluence is high, you're using a lot of resources, it'll increase your impact. And technology can be one of two ways. Maybe an increase in technology that uses fossil fuels, that's going to increase your impact. If it's technology that's actually mitigating your impact, then it's going to lower the impact. But obviously, the more resources, the more people you have, the more resources they're going to use. more fossil fuels, more building materials, more food. Also, with urbanization comes more affluence, right? So more stuff. And so obviously those are more resources. And so if you look at the amount of vegetation, the amount of water, the amount of wetlands, all of these resources up here, kind of resources, maybe that's the best graph I could find, but you get the drift, right? All of these things are going to decrease with urbanization. The more area I have built up and the more people that are living in one place, the more resources that are going to be used. And the more economic growth you might have, which means that I'm going to use even more. So it could be a cycle. Urbanization affects water. The more people you have, the more water you're going to use. And so especially interesting is wells that are located in coastal areas, and those pump fresh water for our urban centers, which most of our urban centers are on coastal areas, at least here in the United States, if you think about it. But when that happens, you have the possibility of actually pumping salt water into your freshwater supplies. And so that is called saltwater intrusion, and that is not very good. Obviously, we have an influence on the carbon cycle. You have this increase in combustion, so they're of fossil fuels, so increased cars, increased mass transit, even though mass transit is good, right? But right, you have an increase of all of that in an urban center, increase in industry, and so therefore with the combustion of fossil fuels, carbon dioxide will go up. We also generate a lot of waste when we're in a city. I mean, everyone generates a lot of waste, but it's concentrated, right? So you have this increase of trash and landfills, and so when landfills are degrading as they're exposed, it can release carbon dioxide into the atmosphere. Or at the same time, when they're covered over, they actually turn into methane because there's no oxygen there for the decay. And so instead of creating carbon dioxide, methane, which if you ever go by a landfill, there are these pipes coming out of it like a capped landfill, and they're trapping the methane. Hopefully they're burning it for energy and not just letting it out into the atmosphere, because methane is a very, very, very strong greenhouse gas. In urban centers, we have a lot of impervious surface. So asphalt, buildings, sidewalks, you name it, in an urban center, it's probably not going to allow the infiltration of water. And so you end up with a lot of runoff, so you have a lot of flooding. And then also you have a decrease in groundwater recharge. So obviously your water supplies are going to decrease as well. And finally, people who are in city centers actually have a small footprint because you're building up as opposed to out. But we do build out, right? We have urban sprawl. So this is all part of urbanization, right? Our suburbs here in Stamford are part of the urbanization because we have a city center and we've sprawled outwards, right? The American dream with white picket fence and 2.5 kids and a dog, right? Everybody wants their own little piece of paradise. I mean, of course you do, right? You can blame them. Or maybe you don't, and that's okay too. But anyway, you have this movement outside of urban centers into suburbs and rural areas. And so in doing so, people need to get back into the city. So you have this increased automobile use, more impervious surface because it's not just concentrated in one spot. You have a lot of roads, a lot of driveways, and it just has a larger physical footprint on the land. And then because I like my green lawn, you're watering your lawn, you fertilize your lawn, lots of, extra fertilizer going into water, surface water there.